Hey, what's going on guys? Welcome back to another video in a Node.js for Beginners series. So in this video, we will deep dive into asynchronous programming in JavaScript, and we will understand topics like blocking, non-blocking, code execution, callback hell, promises, and async await. So make sure you watch till the end and make the most out of it. These topics are very important topics when we learn Node.js, and we will cover each topic with some examples and easy explanation. So if this sounds interesting, then stick around. Also, don't forget to subscribe the channel and press the bell icon so that you don't miss the videos like this one. So let's get started. Alright guys, so today's video is sponsored by ZEGOCLOUD. ZEGOCLOUD is a global cloud communication service provider that enables enterprises and developers to easily and quickly obtain real-time audio and video communication capabilities by integrating a single SDK. And recently they have introduced UI kits and UI components that will help you to build the apps faster. As a developer, if you want to integrate a voice calling in your project, then you can simply sign up to ZEGOCLOUD and you can get up to 10,000 minutes free for every month. So if you want to sign up, then you can click on the start free trial. So you can create your own account. I already have an account. So if I go and log in, then you will see that there is a dashboard, and here you can create your application and you will get the configuration which you can use in your application. Now let's say that if I want to integrate a video call feature into my project, I'm going to click on the video call, and here you can read about the SDK. So if I go to the video call and I click on the call kit, then this is the call kit, and you can integrate this with the JavaScript web application, and you can also use it in the React Native. So if I click on the React Native, then you will see that how we can integrate it with the React Native application. So here you will find all the details and all the instructions how to integrate. So here you will find all the recommended resources in order to use the call kit in the project. So if we click on the quick start, then we will see that how we can integrate this SDK. So we can have the yarn commands, we can use those yarn commands, and you can find all the details of the integration with the project on this link. And you will also find the GitHub repository where you will find the sample code of integrating the call kit. So you can give a try to use the ZEGOCLOUD in your project and build some interactive communication features like video calling, live streaming, voice call, and you will find all the links related to the ZEGOCLOUD in the description of the video. So go and please check it out.
Alright guys, so first we will try to understand what this synchronous code is and how this synchronous code execution happens. So I'm just going to write some console.log and I'm going to do task 1. Alright, and I will copy this. So I'm going to copy this and I'm going to do here task 2 and task 3. And if I save this, then we will see that the execution will happen sequentially. So first the task 1 will be logged, and then task 2, and then task 3, and that is very obvious. So this is the synchronous execution of the code. One code is executed after line by line, but there are some of the tasks which you see that actually blocks your execution, and such tasks are like if you want to call an API and you never know that how much time the API going to take to respond you back, and in such cases the execution of the code will stop there itself until you get the data back from the server. And there you can see that there is a blocking code because the execution will halt until you get the response back from the server. So let me create an example which actually shows us the blocking code. So what I'm going to do, I'm going to write a console.log and I'm going to log here start operation. All right, and then I'm going to write a function sleep, and it's going to take an argument milliseconds, and then I'm going to create a variable start time, and it's going to take the current time. So I'm going to do get time. All right, and then I'm going to create a while loop here. So that while loop will be taking the new date dot get time. All right, and if this time is less than the start time plus the milliseconds which I am going to pass into my function, so I will add that millisecond. And before adding this, what I need to have one more console log here. So I'm going to add a console log here, and I will write here operation is running. All right, and then inside this I'm going to console dot log in progress, and the last I'm going to console here operation is done. All right, and once this operation is done, then we will do something. So let me console here that do thing else. All right, so now let me walk through this code, what actually we are trying to do. Let me call the sleep here. So I'm going to call the sleep here, and I'm going to pass 1000 milliseconds, which will be the 1 second. So what actually we are going to do here is we are trying to create a delay of execution of our code. So what is going to happen? First, it's going to log the start operation, and then the function sleep will be called. When this function will be called, we are actually taking the time of that part, and after the time this operation is running will get executed, and then this is going to be in a while loop until this condition is satisfied. The execution of the code, which is this console, and the last console, is going to get blocked, and the execution, once done, then only the execution of the other code will happen. So let me show you. If I save this, so now if I start, you can see that first we have the start operation, then operation is running, and then it's trying to execute this condition, and it is going to block my execution of the rest of the code until this condition is satisfied. And this is called the synchronous programming, where your code gets blocked until it's get executed, and then the remaining code will get executed. So this is the blocking code. So this can be sometime lead into a bad user experience, because when you do a synchronous code, you cannot write a performant application. Let's understand this with some slides. So when the synchronous code execution happens, what is actually happening under the hood? So under the hood, the JavaScript runtime engine consists of two parts. The first part is the heap, where the memory allocation happens, and the second part is the call stack, which is a single thread which the JavaScript browser has to in order to execute the JavaScript code. So in the call stack, you will see that there will be a global execution context, which is, you can say, as a main method, and we are going to take the same example which we saw in our Visual Studio code. So you can see that we have the same example here, and the code execution will happen line by line, starting from the first console log, which is the start operation. So the start operation is now coming into the call stack, and then in the call stack, once it get executed, we are going to see it on the console browser. Once it is done, the next step happens is the function call of sleep method. And when the sleep method comes into the call stack, it's going to call the function sleep. And inside the function sleep, we can see that we have a console log, which is the operation is running. So in the next step, what will happen? There will be another stack will be added on the sleep, and that will be the console log operation is running. Once this console log is printed on the console, the next execution will happen for the while condition. So the while condition, it's going to halt our execution until this condition is satisfied. That means the rest of the code execution will be blocked here. So once the condition is satisfied, you will see that the console log in progress is now in the call stack. And once the in progress is logged into the console, the next execution will happen of the operation is done, and that will come into the call stack. And once this is executed, we will see on the console log, and now our sleep method is executed completely, so it will be removed out of the call stack. And in the end, we will have a console log which says do something else, that will get executed, and we'll see it on the console browser. So this is the sequence which we actually saw in our console when we executed the code in the Visual Studio Code. So let's go back to the Visual Studio Code, and then let's try to convert this synchronous code into an asynchronous, and then let's see how actually the JavaScript engine will handle the asynchronous task because it only has a single thread, which is the call stack, then how it's going to handle these async tasks and how it's going to make our code into a non-blocking code execution. So let's get back to the Visual Studio. So now we can see that the same sequence is console in the browser. Now let's try to convert this synchronous code into an asynchronous. I'm just going to remove this part and I will also remove this as well. And what I'm going to add here, I'm going to add a set timeout function which get executed asynchronously. So I'm going to write a set timeout, and the set timeout function actually accepts another function as an argument, and that function is known as the callback. We are not actually going into the deeper part of callback, promises, async, await, which are the way you execute your code in an asynchronous manner. We will be seeing these in the coming videos, but now let's just focus how this execution happens and how this asynchronous task is handled. So I'm going to write a arrow function here, and that arrow function is going to do a console.log, and now I will just shift this console here, and this execution will happen with some milliseconds or with some delay, which we are going to pass from our sleep function. All right, and now if I save this function, the execution, I just want you to think for some seconds that how this execution sequence will happen. We obviously know that the first execution will be the start operations, then the sleep method will be called, and once the sleep method is called, the browser will execute the console log operation is running, and after that it comes to the set timeout. But this is going to be an asynchronous execution. It will not wait for the 1 second in order to finish this execution of the set timeout. It will just go on to the next statement, which is the console log do something else. And once this is printed, so now if I save it, then you will see that first the start operation happens, then operation is running, and then do something else, and once it is get executed, it actually prints the operation is done. So this is in an asynchronous manner, so it is not waiting for a set timeout to get executed and then goes to the next statement, unlike what we saw in the synchronous, where it actually blocks your execution flow until the condition was matched. So that's the difference between the async and asynchronous. Now let's see actually how this asynchronous thing happens in a single thread, because we only have a call stack. So let me get back to the slides. All right, so now we are back into our slides, and we have the same example which we just saw in our Visual Studio Code, and we have very similar structure. We have a call stack, we have a browser console. So the first thing happens is the start operations comes into the call stack, and after that it get executed. The sleep method is called. Now the sleep method is in our call stack, and after that the console log operation is running, is coming into the call stack, and once this get executed, it gets printed on the console, and then we have the set timeout, and here the CB refers to the callback function which we pass the arrow function. 1000 is the milliseconds we passed. So what happens actually, the call stack immediately, as soon as it sees that a set timeout is in the call stack, it will just pop out the set timeout, and it actually gives this set timeout to the web API. So the browser already have this web API, a separate thread, which is actually going to execute your async functions like set timeout, set interval, or event listener. So all such callback events or the functions, whenever they enter to a call stack, the call stack actually sends them to a web API for a separate execution thread. So here we can see that the set timeout is in the web API, and next what is going to happen, the do something else will get into the call stack, and once it is printed on the browser, the web API what is going to do is set timeout function will register itself into an event table in the web API. And once it is registered into the event table, the next thing is going to happen is the event table will put this callback function into a task queue. So all the callback functions like the set timeout, set interval, add event listener, or ajax call, So all such asynchronous tasks has a callback function, and that callback function is passed to the task queue. Once it is passed to the task queue, it will wait for the call stack to get empty and all execution gets finished. Now we can see that the call stack is empty. What is going to do? There is a thing called event loop. So all the events from the task queue are now passed to the call stack, and now our execution of the callback function is done by the call stack, and we get printed the operation is done. So this is how the under the hood the async execution happens, because call stack is a single thread, and on a single thread we cannot perform the async task. So that's how we saw how the asynchronous execution happens in JavaScript. So let me get back to the Visual Studio Code. All right, and this is what the sequence we actually saw when our execution happened by the JavaScript runtime. We saw first start operation, then operation is running, do something else, and then we got the operation is done. So that's all we have. We know that how the execution is happening in JavaScript and how JavaScript handles the asynchronous task with a single thread. And I saw a lot of developers, whenever you just ask them is JavaScript a synchronous or an asynchronous, they promptly will answer me that it's an asynchronous. But no, JavaScript is actually a synchronous single threaded language, but you can handle the async task using callback, promises, async await, which we are going to see in the next videos. Alright guys, so let's understand what is this callback function. We know that there are regular functions which we usually write in our code. But then what is this special function which is called as a callback function? So a callback function is a function which is passed as an argument into another function, and the other function will execute this callback function at later point of time. So whenever I say a callback function, most of the JavaScript developers they think that we are talking about the asynchronous task. But that's not the case, because callback by themselves are not asynchronous. They are synchronous in nature. And let me show you that with an example. So what I'm going to do, I'm simply going to write a function async task, all right? And we are going to pass another function which I'm going to represent as cb as callback, and then I'm going to call this callback function at later point of time. Now the next thing I'm going to do is I'm going to call this function, and while calling this function I need to pass a function as a callback. So I'm going to do a arrow function, and I'm going to do a console dot log, and I'm going to pass name, all right, and then I'm going to define the name here as the page. All right, before I save it, I want to do some more console log here. So I'm going to do console dot log task start, all right, and I will be adding one more console log here which will be task running, and the third one I want to do is task end. And before I do this, let me write the page here directly. Okay, and if I save it now, then you will see that it's very obvious. First we are going to console the task start, then the console will happen for the task running, and then the console will happen for the page, and then the task end. But there's no asynchronous part here. Everything is happening in the synchronous mode. All right, the next thing what I'm going to do is now I'm going to change the page to name. And as we know that a lot of people think that callback is an asynchronous, but now if I save it, I want you to think that what will be the execution. Is the execution will still be the same or not? And if I save it, then you will see that I'm getting an error. And why is this so? Because callback are asynchronous, and then why it is giving me an error, why it's not able to find the name here. And that is because callback themselves are not asynchronous. They are synchronous in nature. We have to make this callback function into synchronous mode so that the complete JavaScript file is compiled first and all the variables are allocated to the memory, and then our callback function is called. So in order to change this function into a callback function, we need to use something like set timeout. So let me use a set timeout here. So I'm going to use a set timeout, all right, and this set timeout is going to take two arguments. One will be the callback itself, and another I'm going to add a 0 second. So this 0 second is a very small amount of time, 0.000 something. I just need to add some time, so I'm adding it 0. And now if I save it, then our function will get executed properly. And now you will see that this callback function is taken out from the execution flow, and then the complete JS file is compiled. All the variables have been allocated into the memory, and then my callback function is call. So in this way, you actually convert your callback function into an asynchronous execution. There are other ways also doing this. You can also use promises. You can use async await if you want to do a async execution task. But let's keep them aside. Let's focus more on this callback. The another thing I want to show you is what is a good way of handling the errors on callback. So there's no specific standard of handling the errors, or there's no a specific way of writing it. But when Node.js came out, we usually started writing the error as the first argument in the callback. And let me show you what is that. So I'm just going to remove this, and I will also remove this and this. And the next thing I'm going to do is I'm going to add the arguments in my callback function. So the first argument is the error, and the second argument is the data. All right, and let me add this. All right, and now the next thing we can do is if we have an error, then we can just simply throw the error. Else what we can do, we can just console log the data, which is we are getting as a data here. So that's it. I mean, the callback function will always have the error as the first argument and the data in the next argument. So that's how, I mean, you can remember that when you use a callback, you will always get the error as the first argument and you get the data. That's how from the Node.js it started, that this is called the error first callback. So now if I want to pass this error, so what I'm going to do is I will just create a function in my set timeout. So I created an arrow function and it will still be the same. And now when I call my callback function, there is an error. I can pass the error and this error will be taken as the first argument. Now if I save it, then you will see that I get an error in my console. But if you don't have an error and you need to have a data, you have a data, then your first argument will be passed as null because you don't have an error. And your second argument will be your data. This is the data from server. And if I save it, then you will be able to see that now I can see the data. So I mean, this is one of the standard way, usual practice to handle the errors on the callback. We use callback functions very frequently while writing a Node.js application. The other thing I want to show you is now what is this callback hell? So we know the callback, we know the callback functions, how it happens in the asynchronous mode, but what is this callback hell actually? So this callback hell is a very interesting topic which gives you an idea about our understanding with the async callback functions. So if we are using the callback functions and they are executing in an asynchronous mode, but you have that your logic of sequences should be executed one after the another in a sequential way, then how you're going to achieve this? So if this code execution was a synchronous mode, let me show you with an example. So what I'm going to do is I'm going to remove this and I'm going to write a new function called make API call, and this is going to accept a callback. All right, and then I'm going to use the same timeout function and it will be an arrow function, will be executed in 0 seconds, and I'm just going to do a console.log. This is async task execution. All right, so now the thing is that once my callback function is get executed, I need to make an another call. So in general, you can think about that in real projects. We have a lot of scenarios where we actually make an API call, and then once we get the data back from the API call, we need to make an another API call. And how this, if this is in a synchronous mode, then it will be a very easy. So we just need to have, like, we will be having log this. So all this will happen in a very sequential way. So the first line number 12 will get executed, then line number 13, then 14 and 15. So it was very easy if the code execution was in a synchronous mode. But if the code execution is an asynchronous mode, then what we will do, we are first going to call a make API call. All right, and this is going to take a arrow function. All right, I'm just going to give an empty arrow function just for the reference. And now once this callback function is called, I need to make an another API call. So what I'm going to do, I need to make an another API call. All right, and once my second API call is get executed, I need to perform some other tasks. So let me perform an async task here. So I'm going to write an async task which I want to be in an asynchronous mode, and once it is done, I need to make an another task. I need to make an another task, and this way this nesting happens. And when you have a multiple nested callbacks, it results into a callback hell. And why is it so we call it as callback hell? Because now you can see that it's a very nasty the code syntax, I mean, you need to remember that this syntax get close here, this syntax get close here, this syntax get close here. So I mean, in the mind you need to remember a lot of sequence, and it's not that much readable. So what we are doing here is that we are doing an asynchronous execution call with the chaining of callbacks, and then we end up with the nesty syntax of the nesting of callback functions, and which is very hard to understand and readable, and this is called the callback hell. So in order to do these type of executions, or in order to do these type of logical or chaining of the callback or chaining of the asynchronous tasks, then we use usually promises or async await, which actually have a more better way of writing the code and way simpler to understand. So I guess that's all we had for this callback and the callback hell. I hope you understand this core nature of this callback and callback hell, how they works and how we convert a callback function into an async execution. Alright guys, before we jump into code, I just want to explain you what are promises in a very layman language. So a father promises to his son that he's going to gift him a car if he scores 90% in his academics. Now there can be two possibilities. Either the father fulfills the promise to his son, which is called the resolve, or he failed to fulfill the promise, which is called reject or the fail. And very similarly in JavaScript also we have promises which takes two arguments. Either it's a resolve or it's a reject. So let me show you this with an example. So I'm going to create a constant promise. And in order to create a promise in JavaScript, we use new keyword and then we write the promise. And this promise takes a function which has two arguments. So I'm going to create a function. I will be using an arrow function and it will going to take two arguments. The first argument will be resolve. Either the promise is resolved, and the second argument will be the reject, and then we perform some operations. So let me perform some operation. I'm going to do a console.log and I'm going to write async task execution, and then we can write some conditions here that if this async task execution is fulfilled, which is true, then that means the promise is resolved. So I'm going to call my resolve method. But if it is not resolved and it gets rejected, then I'm going to call a reject method, which is this reject method. And that's it. This is the simplest form of a promise in JavaScript. So now next question is, how do we interact with this promise? So in order to interact with this promise, we simply use the promise dot then method. And using the dot then method, it accepts two functions. The first function is called when the promise is resolved, and the second function is called when the promise is rejected. So we can use two functions. So I'm going to use an arrow function here, and then I can have another function which is for the reject. All right, so now I have two functions, and now let me add a console.log and I'm going to write a success, or let me use past. All right, and similarly I can write the another console here, and that console will be failed. And now if I save it, then you will see that my console log for async task execution is logged, and we have made a condition of true which gets satisfied, and my resolve is called. And when the resolve is called, the first method in the then function will be called, and that is the console log passed. But what is the case is that this promise is not resolved, it got rejected. So in that case, I'm just going to do a false, and if I save it, then it's going to give me failed. So in this case, the promise is failed. We can do one more thing here. Instead of passing this here, we can actually pass the values from the resolve method. So just take an example that you made an API call, and that API call is now success, and that API call has given you some data. So I'm going to write some data here, person, and this person have a name property, and I'm going to say the page. All right, and I will pass this person as an argument in the resolve method. All right, and let me create here another constant as an error, and this is going to have error code. I'm going to give 1001, and I will pass the error in the reject method. All right, so if I want to use the value of it, then I'm just going to use a val as an argument here, and I can simply log the console here. And now if I save it, then you can see that I get the data which is being passed in the resolve method. Similarly, if your promise is not resolved and your promise is rejected, then you can simply take the argument as error and you can type the error here. And this is going to give you the error. I want to show you one more thing, that with this then you can also make a catch of your error. So if I want to catch the error, I'm going to write simply catch, and this catch will have a arrow function, and I'm going to do a console.log failed. All right, and if I save it, then you will see that I am not able to see the failed. Is because I have another function in my then, which is the error function. So what happens in case you have missed the error function in your then method, then it's directly going to call the catch method. Now in this case, you will see that the promise is rejected and an error is thrown and an error is handled in the catch section. And you can also use finally here, finally, and this is going to take a arrow function, and I can do a console.log, and let me do some cleanup. So this finally will always be called when you interact with the promise. So it's going to give me the failed, but it's also going to call the finally method. You can do one more thing, that if your promise throws an error, then you can actually write the throw an error. And what is going to happen is when you actually throw the error, it's going to call the reject method by default. So when you throw the error, it's going to automatically being catched in the catch function, and if I directly write here, then it's going to give me an error, and that's where we are getting the error. So this is a case where you actually had a promise and which is immediately resolved or rejected. But there may be a case that you have a promise which is being already resolved and now you want to interact with it. So you can also do that, and let me show you the example. So I'm going to do a let p, and we have a promise which is already being resolved. The promise is already being done. So I can do directly promise dot resolve, and I can do the execution is done. So this is a promise which is already being resolved. And if I want to do the reject, then I can similarly do the reject as well. So I'm just going to copy paste, and I'm going to change this reject. Execution is rejected. So now even though the promise is resolved, we can still interact with using the then handler. And this part we cannot do in the callback functions. Once the callback function is executed, you cannot attach anything to it or you cannot interact with it. But that's not the case with the promises. And that's where the promises has advantages as compared to the callback functions. So what we can do is, if I want to interact with it, I'm just going to write p dot then function, and I can do the console.log val, and I will pass the val here. All right, and now if I save it, then you will see that we get the execution is done as a console log. But this was not possible if we have used the callback functions. Next thing I want to show you is that promises are by default asynchronous in nature, whereas we saw that callbacks, they are not asynchronous by default. We have to use set timeout function in order to make it as a asynchronous execution. So let's go to that example again. So this was the example we used in our callback functions video, and if I save it, then we know that we are going to get a reference error because callbacks by default are not asynchronous. Now let's convert this into promise and let's see that. So for converting this to promise, I'm going to remove this and I'm going to return a promise dot resolve. All right, and then what we are going to do is, I'm just going to remove this dot then, and this is going to have an arrow function, and I'm going to do a simple console dot log name. And now if I save it, then you will see that the code execution happens. So that means the promises are asynchronous in nature. They are taken out of the execution flow and then executed later on. So that's why we get the variable name, as it's already being allocated in the memory, and JavaScript runtime engine will be able to give us the value name. The next thing I want to show you is how we can do chaining in promises. We saw in the callback functions that when we have to do the logical sequence one after the another, we result into the nesting of callback functions, and which gives us the callback hell. So let's see how we actually do the chaining in promises. So I'm going to write a constant p, and that is having a promise which is resolved. just for the sake of simplicity. All right, and it's resolved, and I'm going to write done. And now I'm going to write p dot then it's going to take a argument, and then I'm going to console dot log, and I'm going to print the value. All right, so we know that we are going to get the value as done. But now once this promise is resolved, I want to make a chain, I want to make some another execution. Then what I can do, dot another then, and I can repeat the same thing. I can do a console dot log. But usually when you use chaining in promises, every then handler has to return something so that the other then handler will accept it. So if I want to do that, I need to return something from here. So let me return as done2, and this done2 will be accepted as an argument by the other than function, and then I can do the val. And now if I save it, then you will see that we have done, and then we have done2. And if I want to continue this chain, then return 3 then, and I can simply console.log. So I will accept the val, and I can do the console.log val. And now let me save it. So now you can see done, done2, done3. But if you do not return anything from the then method, then your chain will get break. So you always has to return something. And suppose there is a case that you have an error. So let me do this as a reject. All right, and I'm going to do a fail. That unlike the callbacks where you have the error first callback, you don't need to write the error method in each of the then method. So what I'm going to do, either I can directly write a catch in the last, then I can do the console.log. Well, where I save it, then I'm going to get the fail. So that is one of the advantage, that this code is more readable and understandable by the developers as compared to the one which we saw in the callback hell. The last part I want to show you is the promise all and promise raise. So I'm just going to remove this, and I'm going to write a new function. I'm going to write a make API call, and this function going to return a promise. So I'm going to return a promise, new promise, and this new promise will have two arguments. The first argument will be the resolve, and the another argument will be the reject. All right, and next thing what I want to do is I'm going to write a set timeout function here. So I'm going to write a set timeout, and what I want, that this API call will accept a parameter as time. So I'm going to use that time here, and then I'm just going to do a resolve, and I'm going to write here this API executed in plus time seconds. Now let's try it. So I'm going to call this API, and I'm going to pass 1000 milliseconds. So it's going to take 1 second in order to execute this API. Then I'm going to pass a val here. Let's have the arrow function, and then I'm going to do a console.log, and I'm going to log the val. All right, and now if I save it, then you can see that after 1 second my API get executed. So that's we understood. Now there is a scenario that we want to make multiple API calls, and all those API calls should go simultaneously. We should not want that first one API call will be executed, then the second one, then the third one. So how we can do that? What I'm going to do, I'm going to remove this, and I'm going to make a constant, and I'm going to write multi API call. All right, and I'm going to pass an array. So the first API call is going to take 1000 milliseconds. Second API call is going to take 2000 milliseconds. And the third API call, I want that it's going to take 500 milliseconds. All right, so now I have created a variable multi API, which is an array, and it's going to call 3 times the make API call. So what I want to interact with all the promises only once all the execution of the API is done. So what I can do for that is I can use promise dot all, and in the dot all I can pass the multi API call, and then I can use dot then, and this is going to return me the values. So it's going to return me the array of values, and I'm just simply going to console.log values, whatever values I have being returned. So it's going to return me the array of values. So now if I save it, then you will see that I'm getting an array of the values. We have 3 promises got resolved. The first one API executed in 1000 millisecond, 2000 millisecond, and 500 millisecond. And believe me, these all 3 API calls were simultaneously. They were not waiting for one to finish and the another one. They all went through simultaneously. So if we want to see that why the sequence is 1000, 2000, and 500, if we want to see, because we know that obviously the one with the 500 millisecond will get executed first because it's going to take the less time. And if we want to see that, we can see that as well. So what I'm going to do, I'm going to use promise dot race. So the race is going to return me first promise which is being resolved. So if I do the same thing again, multi API call dot, then it will not return me an array. It's simply going to return me a value. And then I'm just going to do a console dot log, and I'm going to print the value. All right. And now if I save it, then you will see that I only get one value, which is among the 3 API calls which got executed first. And if you save it, then you will see that this API is executed in 500 seconds. And that is very obvious because that is the API which is going to take the minimum amount of time. So that's all about the promises that you should know while writing your projects. And promises is one of the very important concepts in JavaScript whenever we are dealing with the asynchronous programming. Alright guys, so I already have two functions, user login and go to home page. Let me give you a walkthrough of these functions. So the user login function prompts for username and password, and once we add the username and the password, it returns a promise. And this promise contains a set timeout function which is executed after 1000 milliseconds, and the set timeout function actually checks for the username and the password. If they matches, the promise is resolved, and if it fails, the promise gets rejected. If you don't know about promises and how to interact with them, I have a video on it. You can click on the card above and jump to it directly. So the second function, which is the go to home page, accepts the user auth status. So once it gets the user auth status, it returns a promise which is always resolved with a message go to home page, and we add the user auth status. Now let's see how we can call this function and interact with the promises first, and then we are going to do the same thing using async await, and we will see the difference between the promises and using async await function. So what we are going to do, I'm going to call this function as user login, and we can call it using dot then, and when the promise is resolved, it's going to give me a response, and this response will be the user authenticated. So what I'm going to do, I'm going to write a console.log here, and it will say validated user. And once the user is validated, we are going to call the other function, which is the go to home page, and we will pass the same response to go to home page. So this go to home page will also return a promise, so we can interact with the promise using chaining in promises. So I'm going to write a dot then, and this is going to have the response which is going to return. So I'm going to add here user auth status, and in order to get the response, we need to actually return this function. So let me return this here, and here we are just simply going to do a console.log, and we are going to log the user auth status. All right, so now let's save it and let's see what happens. So if I save it, it's prompting me for the username. So I'm going to write the page as username, and I'm going to add the page as password. And if I hit enter, then it says that user enter username and password first, then performing user authentication, then validated user. And yes, the promise is resolved. So we are actually seeing that go to home page as user authenticated. So the user authentication is done, and that's why we are going to go to home page. But what if the authentication gets failed? So let me refresh this, and this time I'm going to add actually some other name, and I'm going to add the page. And if I hit enter, then it says that performing user authentication, but the authentication is failed. And we can actually handle this error using dot catch in promises. So I'm going to add dot catch here, and this is going to take an error. So I'm going to add an error here, and I'm going to add console.log error. All right. And this time if I write page, then it's going to say that authentication failed, which is very correct. So there's nothing wrong with this approach. This is very good approach using promises, but you can actually write it in a more concise and more readable form. You don't need to write dot then again and again. So what we can do is we can switch to async await. Now let's see how we can write the same thing in async await in a very shorter syntax and in a very readable way. So I'm going to comment this out. So when you use async await, you actually need to wrap your async execution into a function. So you can use any function, a named function and function expression, or if you want, you can use a self-executing function. So what I'm going to do, I'm going to write a function perform task, and we need to use async await. So we need to add a keyword here, async, And then what we will do, we are going to first call the user login. So I'm going to call the user login, and this user login function is actually going to return me some response based on the promise get resolved or rejected. So I'm going to capture this response in a constant. All right, and we are using async await, so we actually need to add an await keyword here, so that we have to wait for this function get executed. And now once we get the response, what we are going to do, we are going to do a console.log, and this will say validated user. All right, and after that we are going to call our go to home page method. So for that I'm going to add go to home page, and it's going to take the response, and this is also going to return us a promise. So we need to add an await keyword here as well, and we are going to capture the response in a constant, and I'm going to add the user auth status is equals to await. All right, so now we have captured the response of go to home page. Now we are just going to do a console.log user auth status. All right, and now we just need to call this function. So I'm going to call the perform task, and let's see what happens. So I'm going to add the page. I'm going to add the page as password, and if I hit enter, then we can see that we are getting the same response which we are getting in the promises part. So we have the enter username, perform user authentication, user validated user, and go to homepage as user authenticated. So this syntax is much more concise and more readable as compared to the user login. So this is one of the advantage of using async await, that it adds a syntactic sugar which makes your code more concise and more readable. And what happens in case if you get an error? So if I enter wrong credentials, so in that case it's going to give me an uncaught error, authentication failed. So we can actually handle the error in async await with a try catch. So what I'm going to do, I'm going to add a try here, and then I'm going to do a catch, and we can add all our execution code in the try block. So I'm going to cut this from here, and I'm going to add this here, and in the catch we can simply add an error. So if we have an error, we can do a console.log, and we can log the error. And now if I save it, and now let's see, I enter a wrong username and password, and we will be able to see the error. So that's how you can actually handle the errors in while using async await. But you have to be very careful while using the async await. You have to use the keywords properly. So if I create a function without using an async and I have an await, then it's going to return me an error. Or if I missed out an await and I simply use an async, function will still get executed. So I'm going to add the page. I'm going to add the page. The function will still get executed, but it is going to return me a promise. So you have to write the await in order to get the async await function properly. So I have to add an await here, and I have to add await here. All right, so that's how you use the async await, which are more better in terms of writing the syntax as compared to the promises. Now let's talk about the performance. Is async await a more performant, or a promises is more performant? And let me show you the example which we used in our promises video. So let me copy paste that example. So this is the example we used in our promises video. We have a function make API call which accepts a time, and then function returns a promise, and it contains a set timeout function which will be executed after the time which we passed in the function, and it's going to resolve the promise the API is executed after particular time. And then we have an array of API calls. So we make an API call at 1000 millisecond, 2000 millisecond, and 500 millisecond. And if we want to interact with all these promises at the same time, we use promise dot all, and this is actually going to return all the promises based on the times. So the execution of all these API calls start simultaneously. So it's not that one is executing then the another, then the another. But what if we want to change this into a async await? So what I'm going to do, I'm going to just comment this out, and I'm going to use an anonymous self-executing function. So I'm going to write a function here. All right, and this function is will be self-executed, and inside the function I'm going to do a for. Let's use a for of. So for of, I'm going to use a let request of API requests, and inside that I'm simply going to do a console.log. I'm going to write await, and I'm going to execute this request. So I'm going to execute this request, and we need to return a function instead of returning a promise. So let's return a function from here. All right. And now if I save it, then you will see that the execution happens one after the another. So that's how the performance varies when you use promises and when you use async await. So when you use all the API requests happen at the same time and it got executed based on this. But in the case of an async await, it will wait for the execution of each API and then it's going to execute the next API. So when you use async await, there are some drawbacks which you need to take care. So if you can have a proper mix match of promises and async await, then you can actually write a performant application. But just replacing promises with the async await throughout your project is not a good approach, as you will have a good readable code but you are actually going to decrease the performance of your application. And JavaScript is all known about its performance and fast application and fast execution. So you need to be a little bit careful by using async await. You use it based on case by case, and that's all I have for this video. So I hope you understood the async await very well, when to use, when not to use, and how to use it in context with promises. So if you enjoyed the video, a thumbs up is appreciated. You can connect with me via Facebook or Instagram. I will add the link in the description below. And don't forget to subscribe the channel and press the bell icon so that you don't miss the videos like this one. Thank you. Thanks for watching.